So hi and hello. Welcome to our channel named Alco Exploration. My name is Samir and in this today's lecture we will going to continue the problems on time complexity. So here is our first problem. In the previous video I was calculating the time complexity by actually try running the program, but in today's lecture I'll going to show you how to find the time complexity of problem in more traditional way. Here the value of I is n. Assume that this condition satisfies. Now due to this we will go inside the while loop. So we will be dividing I by 3. So divide I by 3, then again it will check whether I is greater than 1. Assume that it is greater than 1. Again we will divide I by 3. So similarly we will go dividing by 3 till n by 3 raised to k equals to 1. Why equals to 1? Because here at this point the while loop will terminate because I value is equals to 1. So we have to find the value of k now. N by 3 raised to k equals to 1 and it will be 3 raised to k. Now applying log on both sides, log n base 3 equals to k. So value of k is log n base 3. Now what actually k means? K means how many times we are dividing n by 3. So for k number of times we are actually dividing n by 3. Let's take an example and see. Let's take n as 81. So we should be dividing 81 by 3 for almost 4 times. Why 4? Log 81 base 3 is equals to 4. Let's see. 81 by 3 is 27. 27 by 3 is 9. 9 by 3 is 3 and 3 by 3 is 1. So here the while loop will terminate and we are actually dividing 81 by 3 4 number of times. Therefore the time complexity of this problem is order of log n base 3. Now my suggestion will be calculate the time complexity of your own and then watch the video to check whether your answer is right or wrong. Initially I value is 2. Then assuming that this condition is satisfies, so we will go inside the while loop and we will do I into I. So it will be I square, 2 square. Again 2 raised to 2 raised to 2. Again 2 raised to 2 raised to 3. And so on till 2 raised to 2 raised to k. This will be equals to n so that the while loop will terminate. Now we have to again here calculate the value of k. So 2 raised to 2 raised to k equals to n. Applying log on both sides, 2 raised to k equals to log n base 2. Again applying log on both the side, k will be log n. Therefore we can say that the time complexity of this problem is order of log n. Now let's find the time complexity of another problem. Here it is similar to previous one only. In the previous question, inside the while loop it was actually multiplying I 2 times, but here we are doing the square root of I. So initial value of I is n. Now we can write square root of n as n raised to 1 by 2. So we will do the square root of n, so it will become n raised to 1 by 2. Again we are applying the square root for this, so it will become n raised to 1 by 2 square. Again apply the square root, it will become n raised to 1 by 2 cube, and we will be doing this till k number of times. That will become n raised to 1 by 2 raised to k, which will be equals to 2, so that the condition will terminate. Now we have to find the value of k. So 1 by 2 raised to k log n equals to 1 log n base 2 equals to 2 raised to k. This 2 raised to k will go in this side, so k will be log n. Therefore the time complexity of this problem is order of log n. Let's calculate for the next one. Here it is a simpler one. Actually it is similar to while I is less than n, I equals to I plus 1, or we can say I equals to I plus 2. It is similar to this problem only. So here this statement is running for n by 5 times. So therefore the complexity of this problem is order of n. Now initially the I value is 1, then we are actually adding 5, so it will become 6. Again we are adding 3, it will become 8. So inside the while loop we are actually doing I equals to I plus 8. It is similar to this only. So these statements are running for n by 8 number of times. So complexity will be order of n only. Now here this is a crucial. Initially the value of I is 1. Now we are adding 5, then 8, and then we are subtracting by 10. So n upon 5 plus 3 minus 10 will be n upon minus 2. So time complexity will be n, but it's actually the wrong, because here we are decreasing the value I over the time. So we can't have this decreasing function actually. That's why we can't calculate the time complexity when there is a decreasing function. So this is the decreasing function. Let's calculate for this problem. These statements will be this one, this one, this one, and this one. So the order of magnitude of this statement will be 1. Now let's calculate the order of magnitude for this statement. Now this statement j equals to j by 2 will be running for log n times. We have seen why the answer is log n times. Now this statement will be running for log n times only, because this statement is not dependent on this, and it is actually multiplying I by 2. Therefore this statement will be running for log n times. So the whole statement, or we can say the whole problem, is running for log n square. Therefore the complexity of this problem will be order of log n square.